A light disc made of aluminium is kept horizontally and is free to rotate about its axis. A strong magnet is held vertically above. On revolving the magnet about the axis of the disc will rotate in the direction. Okay, what is the doubt here?
Can you explain this question, sir?
It will rotate in the same direction. Huh? That's why a little bit of science camp kind of thing is required. First, it is checking. The person is checking whether the magnet can attract that aluminum plate. The aluminum plate is not getting attracted at all. Did you see the motion of the aluminum plate?
Yes, sir.
Yeah. Any explanation that you can come up with?
No, sir.
The direction of induced current is such that it opposes the change in flux which creates it. To oppose the change in flux, or if it is trying to oppose the change in flux, it's trying to maintain the flux. For that, maintaining the flux, the magnet should be always above the plate. The plate is like this, the magnet is like this. When we move the magnet is going away. So magnet is reducing the flux. But this plate says that no, don't do that. Give me the same flux. So that's why it also moves towards the magnet. It also moves towards the magnet. For example, a solenoid. Let's say there is a ring, conducting ring. Let's say we reduce the current. So what will happen to this magnetic field?
It will decrease.
Decrease. In which direction the ring will go? Towards right or left? If it remains here only, what will happen to the flux through the ring?
It will decrease, sir.
Field lines are like this. Do you know the field lines like this of a
Yes.
solenoid?
Yes, sir.
So what will happen to this field lines? Increase or decrease?
Decrease, sir.
So flux will increase or decrease?
Decrease, sir.
To restore the flux, should it go away from the solenoid or come towards it?
Towards the solenoid, sir.
But let us try to understand it in a more deeper way. What is happening to the flux here, increasing or decreasing?
Decreasing, sir.
So as seen from this side, what is the direction of induced current?
Clockwise, sir.
Clockwise. Very nice. Now the magnetic field is inclined little bit. This magnetic field is inclined. This inclined magnetic field has got this component and this component. Similarly, on the other side also, the magnetic field has this component and this component. Now this component of magnetic field will create what direction of force on this current?
Upwards.
And this component of magnetic field will create what kind of force in this?
Downwards.
So these two forces cancel. But what can you comment on this component of magnetic field and this component of magnetic field? This component of magnetic field for this coming out current, what is the direction of force?
Towards left, sir.
And this side?
Towards left, sir.
So this will get attracted.
Yes, sir.
So this is the complete understanding why the ring gets attracted. Otherwise, you can simply say that ring feels that my flux is reducing. Let me go towards the solenoid and check, restore my flux.
Yes, sir.
Another way to understand is because of this clockwise current, it will become a magnet. Clockwise means south. And this is the solenoid is anyway a magnet. Clockwise means south again. So this is the north of the solenoid and this is the south of the coil. So this north and south attract each other. That way also you can say that this will be attracted. Are you understanding this?
Yes, sir.
So the induced current is such that it always tries to maintain the flux, and to maintain the flux it has now to come, it is supposed to come closer to the solenoid. Now the same thing happens here also. This magnet is going away. So magnet is going away, so the flux is reducing. So it tries to move along the magnet, towards the magnet, so that when it always remains below the magnet, it can preserve the flux. Otherwise, you have to take a loop here and again use the same logic and try to get the currents, induced current, direction of induced current, take that magnetic field, get the force, and you will get that when the magnet is going towards right, the force will also be towards right. Basically, where the magnet goes, there only the aluminum plate wants to go to maintain the current, to maintain the flux, sorry. Are you understanding this?
Yes, sir.
So here also this magnet, if it is moved in a about an axis, the radius r, if you turn it like this thing will also turn in the same manner to maintain the flux, so that whatever part of the disk is below the magnet, like this is same part only remains always. That is what is the best situation. That is what it wants. It wants to preserve the flux. Is that clear?
Yes, sir.
Okay.